Alright, so what I've decided to do so I'm not so grumpy during these videos is to break out some sunflower seeds. I'm going to see if I can do this without annoying anybody. So, what we were talking about is arrays. And in those arrays, there are multiple. That shouldn't be a problem, right? Alright, so recapping what we've done. Instead of creating 10 student variables, one for each student that we're looking at in this class, we went and created one student array that has 10 elements. And so again, we've got this big long array that has 10 elements in it. So when we do this little line here and say student 0 equals Michael, it goes out to element 0, and we refer to it as elements, and it puts in Michael. Michael. Please, somebody, get me a pen board. And that's element 0. And we go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so those are the elements. And so when we say go into element 1 and put in Lindsay, then it will go into this element. So then when it reads it out down here, because what happens, and let's trace through this so we make sure we understand this good. I'll put a stop there and then run this in debug mode after I compile. It gets to that line and it says, okay, let's go in. And notice that it sets I to 0. So I is 0. And it says print student number plus concatenate on whatever I is. So I is 0 plus 1. So it's going to print student number 1 and then concatenate on a colon and then go look in the students array at position 0 because that's what's in I, right? I is 0. So we look at students element 0. And then we come in and I is incremented, and now we're going to look at, we're going to print out student number 1 plus 1 is 2, so student number 2, colon. Let's go look at students element 1. So then it goes out to memory, looks and sees what's in element 1 of the array, and that's what it prints out. And so on and so forth. If we keep tracing through this loop, then that will just keep incrementing, and then it'll be 4 and 5 and 6, and it'll keep looking at all the elements until it gets to element 9. Actually, we're going to get an error here, and that's actually a good thing. We'll get an error here that says array index out of bounds exception. Now, if you can pause and rewind. So go back and look and see what value I was before I pressed that button that made it get that error, and you'll see that it's it would have been I equals 10, and the problem is this loop goes up to 1,000 because that's what I had it when we finished the last video, and so it tried to access element 10 of the array. Well, the problem is there is no element 10, right? It doesn't exist, and so what it's telling you here is that index is out of bounds. It's not in the bounds of the array. It would be the same thing if we tried to access element -1. There's no such thing, and so we would get an error. Well, so what do? In this case, the students array, one of the properties of an array is that it gives you the length of the array. And so rather than going up to 1,000 and risking running out of bounds, I can say how big is that array by using students.length. And now I want to go while I is less than the length of the array. Well, wouldn't I want to go till I is less than or equal to? Let's try that. And we'll get the same error because the length of the array is 10, but because we start numbering at 0, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, element 10 doesn't exist, and so we don't want to go to the or through the length of the array. We want to go to it, right? While I is less than the length of the array, then keep incrementing each time. All right, very good. So arrays are extremely useful when we have this like type of information. If we're storing a bunch of social security numbers, or if we're storing a bunch of test scores, or if we're storing a bunch of temperatures, whatever it is, as long as it's this idea that it's the same type of variable. So there's a couple of rules that go along with arrays. One is that they have to be the same type of variable. We can't say a string array and then have an integer in there, right? An integer type. We can create an integer array. So we can say integer array test scores and set it equal to new int array with however many elements, 25 elements, and that's going to store the test scores for those 25 spaces. I can't store strings in there. If I create a double array to store temperatures and set it equal to a new double array with 100 different temperatures, I can't put anything else in there. Does that make sense? So it has to be the same type. The other problem that we run into in arrays is that if I store 100 elements in the array, that's all I can store. If I don't use up all 100, there's still 100 elements there because that's what I declared initially, right? And if I want more than 100 after I've got in and am adding, I can't just say add another one onto the array. So those are some of the limitations of arrays. We can only have the one type, and we can only have as many elements as we declare. Now the good news is we can declare a bunch of elements and then just not use all of them, but is that really a good solution? Anyway, those are just some of the concerns we have with arrays, but this is how it works. So we declare it with the square brackets, and then when we access it, we're saying what number of the array do we want to access. It's almost like the example that I've used before is like it's an apartment building, right? You're getting a bunch of apartments, and this is just the number to say, okay, where does the mail go? Which door do I go to? This is so it's all the same address. The physical address is the same. We're in the same array, but we have to have a way to differentiate where in that array are we, and we do that by this number, which represents the element number of the array. It's like the apartment number in the building. All right, so arrays are as simple as that. And like I said, we use them a lot with for loops because then we can walk through. We start this count. Now, if I wanted to start at the end of the array instead, I could say go out to the length. I don't want to be at the length, remember, but the length minus 1 to get that last element in the array. And then I could say while I is greater than or equal to 0, I want to go down to 0 and then minus minus each time. Well, if I did that, then it would print them in reverse order, right? Beginning at the end, going out to the element 9, looking at that first, and then down to element 8 and 7 and 6 and 5, 4, 3, 2, 1. Well, actually, element 0 would be the last one. But we're printing out I plus 1, so it'd be 0 plus 1 is student 1, right? We got to get used to this zero-based numbering. But that's how arrays work. Very useful, great way to store data if the situation fits. And so we just have to always look at that question. Is it like type of data? Are they all strings? And do they represent the same thing? And it's just a number that's changing. Whenever we see that situation, we think on that automatically arrays. All right? Very good. Spencer out.